So now we're going to dive into section 4.2, which is going to be tools and algorithms with arithmetic. So we're going to do some practice with an Egyptian algorithm, a Russian method. We're going to look at the lattice method, which is more commonly used in our elementary schools. And then we're going to look at multiplication using Napier's bones. So an algorithm is really just a method or a process for solving a mathematical problem. Often we treat it like it's this higher idea and it's very difficult, but in fact it's just how we solve a problem. So it depends on how complex the problem is. The Egyptian algorithm is an ancient method of using multiplication that can be done by hand because it only requires doubling numbers and utilizing addition. So this is a really interesting way to work with your students that might be struggling a little bit in multiplication. So if I want to use the Egyptian algorithm to multiply two numbers, let's call them A and B, I'm going to form two columns with the numeral 1 at the top of the first and one of the numbers, let's say B, to be multiplied at the top of the second. So I've got 1 and B. I'm going to double the numbers in each column repeatedly until the first column contains numbers that can be added to A. Then I'm going to add the numbers in the second column that are next to it. And so this sounds really abstract, so let's take a look at what this actually looks like here. So if I'm looking at this to multiply 13 and 24, so it's much easier to see how this works with actual numbers. So I put that 1 in the column, and I put 24 in the other column, so that would be my B number. And I'm going to form additional columns that double each time. So 1 doubled is 2, 24 doubled is 48, 2 doubled is 4, 48 doubled is 96, 4 doubled is 8, 96 is doubled to 192. And we're going to stop there because I can get 13 from adding 1, 4, and 8. So because 1, 4, and 8 add to be 13, the way I can solve this multiplication problem is by adding the corresponding values in column B. Why on earth would we teach our students this complex method? Well, because they're developing multiple skills, right? They're working on their double addition facts. They're also working on adding sums of multiple numbers. They're working on problem solving skills to figure out what numbers do they need to add to get to 13. So it's not about the process they're using for this specific question. It's about the skills that this question is building in the student. If I want to use the Russian peasant method, this is another way we multiply by hand, so it's another interesting way to do it. Again, it's not about this is the method they're going to use every time they multiply, but it's about building the skills up. So in this method, I'm going to form two columns with the number A at the top of the column and the B at the other. So instead of 1, it's an A and a B. So 13 and 24 would both be at the top. Divide the numbers in the first column by 2 repeatedly, and I'm going to ignore any and all remainders until I get to 1. And then while I'm dividing by 2, I'm going to double the numbers in the second column. And then I will add the second column that are next to odd numbers. And that's going to form the sum of A and B. So what does this actually look like? So this looks like 26 times 15. So if I look at 26 times 15, I would write 26 and 15 at the top. 26 divided by 2 is 13. 15 doubled is 30. 6 divided by 2 is 3. 60 doubled is 120. 3 divided by 2 is going to be 1 with a remainder, but we're going to ignore that remainder, and 120 doubled is 240. So from there, I'm going to add the numbers in the second column that are next to the odd numbers in the first column. So that would be my 13, my 3, and my 1. When I add those numbers up together, I actually get the product of 26 and 15. Again, this is not how we would actually teach students to do multiplication. This is an application of that where they're getting lots of practice with division, they're getting practice with ignoring remainders, they're getting practice with adding multiple digit numbers, and they're getting practice with problem solving. So here's another example of 13 and 19. So I'm going to do the same process by halving all the values until I get to 1 in the first column and doubling all the values in the second column. Then I'm going to take every number that's odd from the first column, and I'm going to add the numbers that correspond in the second number. So 103 is odd, so I'm going to do 19 plus 38, plus 51 is also odd. 25 is odd, so I'm going to add 76. So again, this is not the method that we would necessarily say, use this when you multiply two numbers. This is a method that's developing multiple skill sets within the student's purvey. The lattice method is something we do typically use in schools. This was used in India and Persia as early as 1010, so this is a pretty standard thing. It was introduced in Europe by Leonardo of Pisa, more commonly known as Fibonacci, so you know the Fibonacci sequence. So the lattice method reduces multiplying large numbers into multiplying single-digit numbers. So this is a common core method that we do see a lot. So if I want to find the product of 36 and 568, to do the lattice method, you're going to draw a rectangle, and you're going to draw sub-rectangles for the place values. So I have 568 and I have 36. Now it doesn't really matter which one you put on the vertical versus the horizontal. That's not really important. Based on that lattice method, I'm going to have the 5 and 1 because from the directions, so within each box, I'm going to write the product of the numbers from the top and the side that are above. But, so I have 5 times 3, which is 15. Now notice it's 1 then 5, so I can only have one digit in each triangle. So then I'm going to do 6 times 3, which is 18. 8 times 3, which is 24. 5 times 6, which is 30. 6 times 6, which is 36. And 8 times 6, which is 48. So I'm filling in the lattice rectangles there. Step 3 is that starting at the bottom of the lattice, I'm going to add the numbers along the successive diagonals, working towards the left. If the sum is more than 9, I only write the last digit and carry the first digit to the next diagonal. So I'm going to do 1 plus 1, which would mean I write 2. Here I would have 3, 5, 1, and 1. Write the 0, carry the 1. So here I'd have 0, 3, 8, 2, carry the 1. And then I have 4, 6, 4, 4. Or so I get 4. So 6, 4, 4 is 14, so I write the 14 and I carry the 1. So all of these are ones that are being carried over at the top. So if I read the answers starting at the left side, then across the bottom, I'm going to get 20,000, so 20,448. Why would I actually show my students this? Well, because first it's going to practice carrying digits. It's going to practice your smaller multiplication flags, which is what we need fluency in. We need them fluent in multiplications from 0 to 9. So this is going to continue to build that fluency in numbers from 0 to 9, and they're going to get some good practice on their arithmetic and adding. So again, it's not about the method, it's about the actual skill that's being earned. So then I have 2,356 times 547. So I write out my lattice boxes, I do my multiplication calculations. So if I just have one digit, like when I have 2 times 4 is 8, we would actually put a 0 in the top piece of the lattice. Then I'm going to form my diagonals. I'm going to add my diagonals to get the numbers from here all the way to here, and I get 1,288,732. Now Napier's bones is a bit of an interesting problem. So John Napier is a Scottish mathematician, and he introduced this concept as a calculation tool based on the lattice method. So it's building upon the lattice method. So he had a series that consisted of 11 rods. The first rod, which is called the index, and then one rod for digits 0 through 9. So these are the rods that we're looking at here. I have my index rod, and then I have my Napier's bones, which is generated from the lattice method. Now, if I had these rods physically present, and I wanted to do something like 2,745 times 8, I would choose the rods labeled 2745, and then I would choose the index of 8, and that would tell me what row to look at for my answer. Once I do that and I look at row 8, then I can just quickly do the lattice work here, and I'm able to see the product is 21,960. Here's another example using Napier's bone. So again, if you don't have these manipulatives, it becomes very hard to show this. But if you have the manipulatives or a digital version of this, it can be interesting. So if I'm looking at 234 times 36, well, this time I have 2 digits in the multiplication. So I'm going to choose rod 2, 3, and 4. And I'm going to use row 3 and row 6 as I develop this. And so if I use both of rows 3 and 6 and I write them underneath one another, I'm going to add the numbers diagonally just like I do in the lattice method. So, you know, I have 0 and 0, which is 0. I have the other numbers is 8. Then I have 4, 2, and 4. So my product is 8,424. And so those are all additional multiplication strategies that build additional skills in your students.